Hello everyone, my name is Chuck. You're watching episode 165 Let's Plant. In the last episode, I was working on filling up some of the gaps of the Philippines with a bunch of Sempervivums. I've actually managed to do a bit more over the last few days because I bought a couple of pots of, I think it was Sempervivum calcareum and Sempervivum gillium. At least that was what's in the label. I'm not sure if the ID of the second one is correct, but I'm pretty sure that the other one is in fact calcareum.
Find the idea.
Now, as you can see, I'm holding up another pot of Sempervivum. This is a Sempervivum arachnoideum, and it gets its name from all of those cobweb-like thingies that's forming on the leaves. It's actually part of its growth, and I intend to use this to fill up a few more of the gaps. So let's go do that. Since I'm going for maximum coverage, I'm going to split up this clump, and that way I would be able to cover a lot more of the area. Unfortunately, some of the pups here are so tiny that I'm not sure if they would be able to survive on their own yet. I guess I would leave some of them still attached to the main plant, while the rest that are large enough would be planted separately. So let's go do that. The way that I do it is I just usually break apart and loosen the soil and create a tiny hole so I could just plant it in and fill up or create a little mound around them. Now here's what I hope is a better view. So as you can see, I'm just loosening up this area around here. Then once it's sufficiently loose enough, I just create a tiny gap or a tiny hole, place in the clump, then shift back the soil to mound around the clump. This should be more or less enough. Now I only have to do it for the rest of this cutting, so I'll spread them apart and I'll be back. With that out of the way, we can now move on to the main part of this video, which is playing with grow lights. It's about time we had a change of scenery. You are now looking at my garage, and I've reserved a little spot on this side along the wall, and this is where I'll be setting up my grow lights. Pardon all of the junk. This is a result of several years of accumulating stuff. A lot of these, as you can see, are old kid stuff. So yeah, don't mind them. We are slowly getting rid of them. So as you can see, it is quite dark inside the garage, as expected, because there's no overhead light. And the only light that we have is ambient light from outdoors. This is from outside, and that's from the back. We do have some LED lights on the ceiling, but I don't think that's ever enough. So let me just quickly adjust my camera settings. And that should be enough for indoors for now. So anyway, the reason why I wanted to show you the relative darkness and brightness and whatnot is because several months ago I bought this little kit here. This is a lux meter, a digital lux meter. It basically is an instrument used to measure lux, or the intensity of light in a given area. I got this thing shortly after I got my grow lights because I wanted to be able to do some test measurement and compare against, growing outdoors versus growing indoors under grow lights. And I've been doing a lot of reading for the past week, and I learned that lux is not necessarily the best unit that I should be looking at in terms of photosynthesis, because lux measures the intensity of light on a wider spectrum, while photosynthesis happens on a different spectrum, which is not necessarily equal to that of lux. So lux only tells me one part of the picture. What I really want to know is PAR, or photosynthetic active radiation. Basically, this is the range or the spectrum of light where photosynthesis can happen. So as mentioned in the previous episode, I am an absolute newbie when it comes to grow lights, and I had to do a lot of reading, a lot of preliminary research, and this is what I found. I made a bunch of notes. So the first one is, when we are thinking about light or visible light, we are actually thinking of just a small part of the electromagnetic spectrum. So here's a chart showing the full EM spectrum. So on the left side would be high energetic waves, and that includes gamma rays, UV rays, X-rays, and these things are quite dangerous. They can create damage to cells and tissues. While on the other side of visible light would be stuff with longer wavelengths, and that includes infrared, microwaves, and radio waves. Now, this episode is not supposed to be a scientific lecture about the electromagnetic spectrum, so I'll leave it at that. All you have to know is that we are dealing with a small set of the spectrum, a very narrow band, somewhere within the visible light range, and that is where photosynthesis happens. So the second thing that I have taken note of is that the visible light is a subset of the spectrum, as you can see in the diagram, and it is in the range of 390 to 700 nanometers. The higher the wavelength, the more blue it is, at least on the visible side of things. And as you get further to the right, where the wavelengths are longer, they tend to be more red. So it's from blue all the way to red. Photosynthesis happens within more or less the same range at around 400 to 700 nanometers. However, the whole thing is not usable. There are two main parts or points on this wavelength where energy tends to be higher as far as photosynthesis is happening. So if you look at this graph, there are two peaks, one towards the blue side of things and another at the red side of things. It goes down on the green side, and this is why chlorophyll, the pigment associated with photosynthesis, appears green under visible light, because green is not being used and it's just being reflected back to our eyes. Now, going back to the EM spectrum, photons that are at a shorter wavelength are too energetic. Those are the bits on the left side of the diagram, and that includes gamma waves, ultraviolet waves, and there was one more, X-rays. These waves are highly energetic, containing lots of energy, and they can damage cells and tissues. On the other hand, photons on the other side of the spectrum with longer wavelengths do not carry enough energy for photosynthesis to be viable, which is why the range at which photosynthesis can work is quite narrow. Too energetic and the plants would just die, the cells, the tissues would just be destroyed, while too far on the right with longer wavelengths means that there is not enough energy to sustain photosynthesis. When looking at grow lights, we usually see them in red plus blue or purple, which is the combination of both, and the full spectrum version, which would appear white. And I think one of the main questions here is which one is better. Now, there is a lot of science involved here, and I have not read enough to make a very informed decision, so we will push that out for the next time. I just have to let you know that what I have here is a full spectrum LED, so it should appear white. So over the course of the next few days or weeks, I would be finding out if my grow light is any good. So in my preliminary readings, specifically from a 2014 study titled economic analysis of greenhouse lighting, LEDs versus HID fixtures, it has been noted that many manufacturers claim a significantly higher plant growth due to light quality, which is basically referring to the amount of photons in a certain wavelength. And they produce graphs that show that orange and red photons between 600 to 630 nanometers result in 20 to 30% more photosynthesis than blue or cyan photons between 400 to 540 nanometers. But that curve is based on short-term measurements made on single leaves in low light. More recent long-term studies on whole plants in higher light indicate that light quality may have a smaller effect on plant growth rate than light quantity. Blue light, while not delivering as many photons per joule, encourages leaf growth and affects other outcomes. So again, a lot of sciencey stuff there. We would be learning about that more together in future videos, because currently I would say that my mind is overloaded with a lot of information and I still have to process everything. So once I feel that I've learned and understood enough, I would be creating a separate series of videos on grow lights, including the theoretical and practical applications of what I've learned as far as using them with plants. So watch out for that. So the next part involves checking the intensity of light that we are normally getting. Unfortunately, today is an overcast day, and for control purposes, I would like to have a reading of a typical overcast day just to see how much light we are getting. I took my readings at 2 p.m. and the numbers I was getting was somewhere between 13,000 lux to 14,000 lux. Apart from that, I'd also like a reading of my growing shelves, or the place where I place all of my leaf propagations and my younger plants. That would probably give me a good idea of where to start. Because when doing leaf propagation or growing tiny plants, you tend to filter the amount of sunlight that you give them, and you would not necessarily expose them to the full brunt of the elements. So figuring out the intensity of light in this area might be something very useful for us to know. In this area, I got readings somewhere between 2,000 to 5,000 lux, depending on how close I read to the wall. On lower shelves, there's a huge drop-off in light with a reading below 200 lux. Now that I have those pieces of information, I can now work on my frame. I just have to figure out the lux ranges that I could get depending on the position or the distance between the plants and the grow lights, and compare that against the readings that we just took. Now, before I plug it in, it is important to note that I see a power setting of sorts on the top, and it goes from 25 to 100. Maybe we should take readings at various power levels. Since this is rated at 1000 watts or 1 kilowatt, then those 25 increments mean that each level or each of those points would be roughly equal to 250. So 250, 500, 750, and finally 1000 watts. Without further ado, let me plug this in and set it at 25. Unfortunately, I'm not really sure how to adjust that. I would imagine that I might have to remove the cover, but I'm not willing to do anything at the moment. So I'll just be using it at stock setting and see what sort of readings we could get. Time to plug. Oh, that's so bright. Just to review, outdoors we were getting over 10,000 lux under an overcast sky. Let's see how much we are getting from here. At full power, I was getting somewhere between 1400 lux to 150,000 lux, depending on the distance to the lights. That's quite the range. So as you can see, that's an insane amount of light. It's even stronger than an overcast day. Fortunately, the sun is starting to peek out, so I am quite curious to see what sort of readings we would get this time. Unfortunately, as soon as I set up my camera, we are back to being very overcast. So right now we are only getting 14,000 lux. I guess I just have to wait another day for a more sunny day and see what sort of readings we could get. But at least I now know that my grow lights is stronger than an overcast day. Whether it's going to be as strong as direct sunlight is something that I would have to find out some other time. Having done all of those readings, I think I can now start working on a frame from which my grow lights would hang. Now, as far as design is concerned, it will just be a simple basic open frame, no grow tent for now. The basic setup is I would have this beam somewhere on top with some supports on the side, so something like this, one here and another on the other side, and on the base would be a pair of parallel legs, something like this. So if you could imagine that the whole thing would be something like this, just a simple rack of sorts from where I could hang my grow lights from. Now all I have to do is to measure the available space that I can work in and create a frame large enough that could fit the area. And wow, the sun is out again. Let me go do that reading. Nope, false alarm. The sun is still down, covered by clouds. But at least it is brighter than earlier. It's 184, 18.6 thousand lux. Now let's get building. Just taking a quick break from the build, because as I was building this, I was trying to think about how high I actually want the frame to be. Now, the reason why I originally planned to have something this high or just to use the full height of this plank is because I didn't know how to adjust the wattage being used by my grow lights. Then, before committing to using this length, I thought that I should do a quick search and see how to adjust the grow lights, or at least adjust the power being fed. And I found out that you would need a Phillips screwdriver and just remove the plug on the transformer at the top and just turn the screw until you reach the desired wattage. Unfortunately, I'm not sure. I don't have a wattage meter or something of that sort, so I do not know how much power the grow light is emitting. So what I'll do is just play it by the ear, or at least use my lux meter and see if I can get less than 10,000 lumens. I think that would be great. So here's my lux meter, here's the grow light, and I'm going to do some adjustments now. First, I just want to see if I'm doing the right thing, if I'm turning the right screw. And for that, I just have to do some quick tests. Hopefully, we would be able to see the brightness go up and down as we do this. So there, I am assuming that this came with the highest wattage setting, and by turning it around, yes, indeed, the power went down. So this is the maximum, and I guess this is the minimum. I'm going to set it to the minimum setting for now. Leave it there and see how much reading I get. So I just put back the plug, and I'm going to see what sort of numbers I would get with my meter. We are seeing a very good range, very usable. It went from, well, at this height, this is about 7,500 lumens, I think. Yes, this is 7,500 lumens, and all the way down, this is about 40,000 lumens. Great range, and I think that is good enough as far as seedlings are concerned. So Yeah, I guess I'll go with something lower than this upper shelf here. That way it would still, that way the upper shelf would still be usable, and you know, something like this would be more than enough. And for our final test, let's take some lux readings and see what sort of numbers we would be getting. We're getting anywhere between 25,000 to 10,000 lumens. And this is the final piece of the puzzle. This is a timer, and I've already programmed it to turn on at 8 a.m. and turn off at 5 p.m. That represents more or less the daylight that we have during winter. So yeah, I am more or less simulating the regular day and night cycle that we have in winter. As my first test of using grow lights, I am going to use this with some of my more mature plants, those that would be able to handle a bit of light. This would tell me that my calculations are more or less correct. So I've put together a random bunch of plants. They are mostly, well, all of them are echeveria. And according to the light meter, this is more or less 10,000 lumens. Is it across the board? Let me just check. So there's some attenuation of the light intensity over at the edges. Right here, it's just 8,000. Over at this side is about the same, 7,500, 7,800. Right in front, it's the same, 77,000, 7,100. And I would assume at the back it would be more or less the same, so I could use that to my advantage, just in case I wanted to reduce the amount of light a specific plant gets. So those that require more light would be at the center, while those that require less would be further away. I've gotten an assortment of echeveria. This is an echeveria Gaia, an agavoides hybrid. This is an echeveria elegans, and from one of my previous videos, you would know that elegans is what I usually use as an indicator plant. So this would tell me roughly how these plants would do here, and I would know how to adjust because I'm very familiar with how elegans works. This is an echeveria sagitta, and this is a marzipan, this is a morning dew, and this is a cuspidata zaragoza. All of these would be sitting here for the next week, and I'll see if they make any improvements. Or at least I would be checking if they would start stretching and see what needs to be done. It is a brand new day, and I was hoping to show you what a full reading of direct sunlight under normal clear conditions would be like. But unfortunately, it seems like it is overcast, and it will be the same for the rest of the day. So I guess I'll show you that some other time. So anyway, as I mentioned, the first experiment would just be about some of the more mature plants. But the ultimate goal is to be able to grow my seedlings under controlled conditions inside the garage indoors using grow lights. So if you want to follow the progress of all of that, then make sure to subscribe to my channel. And if you want to know more about grow lights, I would highly recommend my friend Alex's channel. He has a lot more knowledge of grow lights than I do, and I actually use him as my resource for some of the things that I wanted to know. Anyway, as I said, I am just getting into grow lights, and I'll be learning and sharing what I learn as I go along. So keep a lookout for my future videos. So I'll see you in the next episode. Bye.